Hi everybody! So this is our first set of notes using this new screencasting app that I have. So I'm hoping that it goes smoothly. I'm sure there'll be some hiccups and errors in my trying to record this, so just bear with me. A lot of this is new and a little cringy, if you ask me. So we have been looking at or starting to talk about matter, right? Anything that takes up space and has mass is matter. And I wanted to really start this lesson off by talking about properties of matter, okay? Properties of matter are traits that substances have that help you to describe it and distinguish it from other types of matter. Okay, we categorize matter in terms of either physical properties. These are properties that you can observe or measure, and they don't change what the substance is made of. Okay, a physical property might be something like color or size, mass, those sort of things. When you measure them, you look at them and observe them, you can help to describe a substance. And no matter if those things change, the substance itself would stay the same. There are also chemical properties, and chemical properties are these traits that describe how the substance will change when it interacts with another substance. Okay, so we're looking at ways we can describe and discuss or talk about matter. All right, and we're going to look at these two properties, physical properties and chemical properties. A little bit more on physical properties. Again, these are traits that help you to describe matter, and the matter itself will remain the same while describing them. Some examples might be solubility. So how well a substance dissolves within a liquid, that's what solubility is. Okay? A physical property of sugar is that it will dissolve in water, but still retains its self. Odor, taste, the boiling point of a substance, these are all physical properties, as well as melting, freezing point, color, size, shape, phase. Those are all properties of matter. Physical properties. Chemical properties, oh, just kidding. Physical changes help you to describe how a substance will change, but still remains the same substance. So if you change the size of something, it is still the same material or substance. If you were molding clay, for instance, every time you change it into a new shape, it is still the same material or the same matter. So you can change something in size and shape or in phase, and it would still be the same substance. So that is a physical change. For instance, if you were to boil water, it's still water even though it is changing into its gaseous form. It's evaporating. If you sublimate, that's when you have a solid substance that changes directly into its gaseous phase without hitting that liquid phase in the middle. Okay, so sublimation is a physical change. When something melts or freezes, it's still the same substance. So that's a physical change. Nothing has changed about its normal chemical makeup. Salt dissolving in water, it's still salt, it's just spread out through and within the water. If you were to tear or break something apart, it's also a physical change because you're just changing the size of it. Tearing up a piece of paper doesn't mean it's not paper anymore, it's just smaller. Again, if you were to reshape or mold something, you're not changing anything other than how it looks, how it appears. You're changing its physical characteristics. Now, a chemical property is quite different. It's going to describe what happens to the original matter when it comes in contact with something else. And when that happens, it becomes something new altogether. None of the original properties would be the same. For example, when you react substances with acids, you get brand new substances that are produced. If something corrodes, if it breaks down, like again with an acid for instance, you can break it down and it becomes something new. And there's also combustion. When something burns, it has become brand new substance that is no longer the same, and you can't get those original substances back. So a chemical change obviously is a change that happens and results in brand new substances. We're very familiar probably with making volcanoes in younger years, and you use baking soda and vinegar to produce that eruption, and that reaction between baking soda and vinegar is a chemical change. When those two substances come in contact with each other, they produce a gas, which is where all that bubbling comes through. That gas is carbon dioxide, and it gets released. And so the two substances you have mixed have now been changed forever. And so that's a chemical change. When you heat baking soda, and that was a nice little interruption from my son. Interruptions like that are probably going to happen quite a bit through recordings that I'm making. So we're just going to deal with it because I don't want to start over. So the heating of baking soda is a chemical change. We use baking soda in cooking because when it's heated it releases gas, which makes all of the things that you like to eat a lot more fluffy and not as dense. And so baking soda, when it's heated, becomes something new. If you were to mix Alka-Seltzer with water, it releases a gas again, and the Alka-Seltzer has now become something it was not before. So that is a chemical change. Baking a pie, burning paper, all of these things represent something new being produced, and therefore represents a chemical change taking place. The easiest way to know whether or not you're looking at a physical or chemical change is to look for these signs. So if you see a lot of heat being released, there's an exothermic reaction, that's a sign that a chemical change has taken place. And on the opposite end of that, you could also have something react and become very, very cold. So there's heat being absorbed. It's called an endothermic reaction. Those are two really for sure instances where you would know a chemical change has taken place and substances have changed their composition. When you see light being produced, this is my favorite. I mean, how many of us love glow sticks? You know, when you get the original package, there's a small glass tube inside the larger plastic tube. And when you break the inside tube and you shake it up, that reaction between the two chemicals produces a light. Now that's a chemical change, and you know that because the light is being produced. The two substances that create that light are no longer the same substances. Again, when you see a gas being produced, that's a surefire example of a chemical change taking place. And then a production of a precipitate. Now a precipitate is a solid substance that comes out of solution and can be seen when you mix certain chemicals together. One of the substances that comes out is one of the elements from one of the other compounds, and it comes out in solid form. I had some videos of this. It's not very fun to watch unless we were together, in which case I could show you these demos. Unfortunately, we're a little limited in what I can and can't show you. Oxidation, that's when something rusts or tarnishes. If you're familiar with leaving your bicycles out in the rain and the elements, you might end up with a rusty bike chain. That oxidation process, that rust, is a chemical change. I would like, as soon as you have finished watching this video of this note set, to go to the Google Classroom and click on the Google Slides that I've shared with you so that you can watch this video right here. It's just going to recap a lot of what I've already said and will help you on your Google Forms Notes quiz. Have a great night.